Hello YouTube, fellow math students and math teachers, and welcome to the first video in my series about sequences. This video is designed to match up with the sequences vocabulary notes from Mrs. DeVore's class. Sequences are a vital part of the Math 1 integrated curriculum in the algebra portion. I teach this unit near the beginning of the year, just as a point of context. In the Mathematics Vision Project textbook, this subject is covered in Module 3 in the Math 1 curriculum. In this video, we're going to go over important vocabulary, as well as do a brief exploration into arithmetic and geometric sequences. Future videos will look at different representations of arithmetic and geometric sequences, as well as some practical application problems from the Mathematics Vision Project textbook. With that, let's get started. In order for us to be on the same page, I'm going to define a few important terms that I will use in future videos. It might be worth it to pause the video and copy down the following terms on your guided note sheet. First, we have a sequence. It's just an ordered list of numbers that follow a sub-pattern. A term is what we call an individual number in the sequence. An arithmetic sequence is a sequence in which we add or subtract the same number between consecutive terms. This number that we add or subtract every time, we call that the constant difference. A geometric sequence is a sequence in which we multiply or divide by the same number between consecutive terms. This number is called a constant ratio. Some textbooks also use the term constant factor in case you want to Google it. Now that we have some common vocabulary, let's look at some examples of arithmetic and geometric sequences. Here we have two examples of arithmetic sequences. The first thing I should make clear is that we read the table as follows. The first term is 1, the second term is 3, etc., down the table. In order to find the constant difference, we find the difference between the first term and the second term. I see in the first table, to get from 1 to 3, I need to add 2. And looking here, 3 to 5, we add 2. 5 to 7, again, we add 2. We see that the pattern holds. If I were to continue this pattern past the table, to term 5, 6, 7, and on, we would just need to keep adding 2 to get to the next term. In the second table, here's the sequence 10, 7, 4, 1, and we can just assume it's going to go on and on forever. In order for me to find the constant difference, I need to find the difference between the first and the second terms. To get from 10 to 7, I am going to subtract 3 every time. And just to check, 7 to 4, we subtract 3, 4 to 1, we subtract 3, and so on and so forth. Again, if I were to continue this table beyond what I have here, 5, 6, etc., we would just need to subtract 3 every time. Here we have two geometric sequences. To find the constant ratio between the terms, we need to look at the first and second terms. For instance, here we have to get from 1 to 2. Remember, we're multiplying this time. I know that 1 times 2 gives me 2. In order for me to confirm that, though, I should look at a couple more of these. To get from 2 to 4, multiply by 2. 4 to 8, multiply by 2. Looks like it holds up. Again, if I want to go beyond the table, I just keep multiplying by 2 every time, and it will generate the rest of the sequence. In the second table, we're again going to look at the difference between the two terms. To get from 27 to 9, I see that I am dividing by 3. Now, here's where this gets a little confusing. We don't actually want to think about it as division. Instead of dividing by 3, we want to think of it as multiplying by the reciprocal. Dividing by 3 is the same thing as multiplying by 1 over 3. In the next video, we'll examine exactly why that is. I just really want you to just keep it in the back of your head, and just remember that if you're so tempted to multiply, don't multiply by the reciprocal instead. Well, the question really becomes, what if you are looking at a sequence and you just don't know if it's arithmetic or geometric? The easiest way to go about solving the problems, I think, is to first assume that it is arithmetic. Check for a constant difference between all of the terms you are given. If the constant difference works for all the terms you are given, cool, then it's arithmetic and you're done. If you find that the constant difference is not constant, say you're not adding the exact same number every single time, that means that you might need to check for a constant ratio. If you do that and there's no constant ratio, there is a chance that it is neither geometric or arithmetic. Either way, it would be a good time to come talk to me just to make sure that you are not making some weird arithmetic error. I hope this video has helped you understand the basics of arithmetic and geometric sequences. We will go more in depth into sequences throughout this video series. As always, if you have any questions, comments, or concerns, feel free to talk to me during my office hours, send me a message, or shoot me an email, and I will help you out. This is DeVore signing out. Please remember, be awesome!